I'm going to finish the multi-choice questions from the 2017 math method paper. First question, the period and range of this function. Notice the domain is at least one cycle, all real numbers. So the period is 2 pi over n, which is 2 pi over 2, that's pi. The range is c minus a, c plus a. And my c value is -1, my a value is 5. So I'll get -1 plus or -5. And it's -6 to 4. Okay? Option C is correct. Next question, we have this polynomial function, and we want the derivative to be less than 0. So we cannot include, let's say, the x value for the stationary points, which is from -3 to 5 on 3. Okay? Just this section, the graph is decreasing. So it's from -3, 5 over 3, option D. Okay, the box contains 5 red marbles and 3 yellow marbles. So 5 red, 3 yellow. We select 2 marbles, drawn at random from the box without replacement. This is the hypergeometric distribution. We would like these 2 marbles to have different colors. So 5 red, we choose 1. 3 yellow, we choose 1. So we have 5 choose 1 times 3 choose 1 divided by totally 8, we choose 2, okay? And the top number is just 5 times 3. The bottom number will be 8 factorial divided by 2 factorial times 6 factorial. So the top will have 15 divided by the bottom, 8 times 7 times 6 factorial divided by 2 times 1 times 6 factorial. So we can cancel them. And then notice that 8 and 2 can cancel to 4. So altogether, we have 15 divided by 4 times 7, 28. Therefore, option C is correct answer. You can also use calculator to evaluate this expression, like for the cast here, NCR, 5 choose 1 times NCR, 3 choose 1. All divided by NCR, 8 choose 2, okay? Anytime you see this phrase without replacement, you can use the counting method, the hypergeometric distribution. Question 4, f and g be functions such that f2 is 5, f3 is 4, g2 is 5, g3 is 2, and g4 is 1. So we would like to get it fg3. Firstly, the inner function g3 is equal to 2. So once I solve that into f, you will get f of 2 equals to 5. So from inside to the outside, therefore it's option E. Question 5, the 95% confidence interval for some proportion of ferry tickets cancelled on the intended departure is calculated from a large sample to be 0.039, 0.121. So we want to find the sample proportion. Just notice the midpoint of the 2 band will be your sample proportion. So your p hat is 0.039 plus 0.121 divided by 2. So you get, let's say, 0.160 divided by 2. And that is 0.080, okay? Option A is correct. By the way, you could also use that to find your sample size, which is a more popular variation of this kind of question on the recent exam papers, okay? So, for example, if I see this 95%, one thing I would do is I'll first calculate the margin of error. The margin of error is 0.121, subtract 0.039 divided by 2. And you'll be able to get something along this line. And for 95% confidence level, I can say, okay, so this bit equals to 1.96, something along this line. Take a square root. The sample proportion is 0.08 times 0.92 divided by n, comma n. You can see actually the n value is roughly 168, etc., okay? So be aware of this kind of variations. Question 6, let's look. Question 6, we would like to find, let's say, the same scale for this graph and all the other graphs. We would like to find the F inverse. So if you draw a line like y equals to x here. And you should be able to get, for example, something like this point to here. And then just looking at the possible graphs, I probably would say something like that and like that, okay? So some kind of symmetry, okay? Some kind of symmetry. So therefore, option C will be the most suitable answer. This is my f of x. This is my f inverse of x. Okay. Question 7. The equation has no real roots when we have an inequality. So this is a quadratic equation. I'm trying to push all terms to one side. So if I push this term to the left-hand side, we have a plus p minus 5 equal to 0. This is my A, this is my B, this is my C. So we would like delta equals to b squared minus 4ac less than 0. Therefore, you get a 4 squared minus 4 lots of p minus 1 times p minus 5 less than 0. Yep, you could get a 16 minus 4 times p squared minus 6p and then plus 5 less than 0. So if you, let's say, cancel everything by 4, you get a 4 minus p squared plus 6p and minus 5. Just be mindful, if you divide everything by 4, you get a 4 here and a 1 here, okay? And the next thing you see is this whole inequality is less than 0. So you actually get a minus p squared plus 6p, 4 take 5, minus 1 less than 0. Now, if you check through the options, we don't have a negative p squared term. So it is important for you to multiply negative 1 both sides. And flip the direction. So you get p squared take away 6p plus 1 is greater than 0, okay? So option B is the correct answer. Right? So that's option B. Okay, next. Question 8 is a very straightforward algebra question. We'd like to isolate this x from an exponential equation. So we say y take 2 equals to a minus 4x plus b, okay? And then we extract this exponent. So minus 4x plus b equals to log base a y take 2. The other thing is we want to, let's say, rearrange this equation so we get, let's say, 4x minus b multiply negative 1 both sides will give you minus log a y minus 2. And therefore, 4x equals to b minus log a y take 2. If you divide everything by 4, you will get x equals to a quarter bracket b minus log a y take 2. Okay, so therefore I would say the answer is option A. Yep, that is question 8. And question 9, we have an average rate of change of the function f of x equals to x squared minus 2x over the interval 1 to a. A is greater than 1. So we have f of a minus f of 1 divided by a minus 1 equals to 8. Something along this line. This is where I really pick up my CAS calculator. For example, define f of x equals to x squared minus 2x. And we solve, let's say, a fraction, f8 minus f1, a minus 1 equals to 8, comma a. And then we could have given that a is greater than 1. So a is equal to 9. All right, so that's question 9. And question 10 here, I just want to mention, again, as in the extended response question before, you should see this notation rather than the matrices in the transformation, or we simply say it's a dilation factor of 2 from the y-axis. And then we have a dilation factor of 1/3 from the x-axis. What will happen is if I call this function f of x, the first one and the second one consecutively. So the first transformation will give me f of x2 f of x over 2, all right? So the substitution is actually 3 sine 2 lots of half x plus a quarter pi. So that is equal to 3 lots of sine x plus half pi, okay? The other thing is when you recognize sine x plus half pi, it can be simplified to 3 cosine x, okay? So this can be done by your CAS calculator, like sine x plus pi on 2. That is 3 cos x. Then, based on this thing, this is the second step. Go from f half x to 1/3 of f of half x. So it's a consecutive transformation. Therefore, we cancel the 3 to get simply cosine x. Okay? So option D will be the correct answer. All right? All right. Question 11 gives me, let's say, two conditions, a local maximum at x equals to -1 and a local minimum as x equals to 3. We would like to find the unknown values in this cubic function. So the conditions we use is like f dash of -1 equal to 0 and f dash of 3 equals to 0. But to get get the question down more efficiently, I'm going to define the f of x. So like if you define a second function, it will override the previous one you defined. So x cubed plus ax squared plus b times x. And then define df of x equal to shift minus x, f of x. And we just solve simultaneously. df of -1 equal to 0, df of 3 equals to 0 for AB. And A is -3 and B is -9. So option D, -3, -9. Okay. Question 12. The sum of the solutions of sine 2x equals to √3 over 2 over the interval is -pi. The interval has an unknown D here. Well, I probably will use this command, zeros, but then remember the zeros only find the expression equated to 0 and the relevant x values. So what I'm going to do is I will type this out on my CAS calculator. And then from -pi less than or equal to x less than or equal to some value here. And the question is actually testing, okay, up to which option can I get the zeros when I add them up, I get a sum -pi. So that is the key thing I'm going to use. And you might find this command also helpful. Sum. I'm going to show you what's happening here. So for example, if I place my CAS calculator side by side, Control I, I'll put the zeros, sine of 2x, take away a fraction, square root of 3 divided by 2, comma x, given that -pi less than or equal to x less than or equal to. Let me try, let's say 3 pi over 4. So I'm able to get, let's say, like this one, okay, like this one. The next thing is if I sum them up. Oh, actually, I'm very lucky. So if I try, let's say, d equals to 3 pi over 4 as my upper bound, then I get these 4 solutions. And when I add up these 4 solutions, I get exactly -pi. So option C, okay? I mean, if one option doesn't work, then try another option. As long as you design an algorithm yourself, this is another key focus of the current study design, abstraction, and put that in a normal language or a solvable equation whatsoever, and then repeat the algorithm, okay? Question 13, we would like to find a statement about h not true. So you might want to define h of x equal to 1 over x minus 1. And then h of x times h of minus x equals to minus h of x squared. That is true. So we don't want to select option A. The next one, if I have h of x plus h of minus x, equals to 2h of x squared. That is also true. Just ignore the triangle here. It's just indicating, okay, the domain might be slightly different. Then h of x minus h of 0 equals to x times h of x. That is also true. Next one, h of x minus h minus x equals to 2x times hx squared. That's true. So the last one, h of x squared equals to h of x squared. That is not true. Okay, apparently. Okay, question 14. I'm going to just write down a few things. The variance of x from this distribution comes from variance x equals to expected value x squared minus ex whole thing squared. I'm not going to use by hand calculation. If only if it's exam 1 question. In this case, I'm going to say, okay, list, let's call it x1 is assigned to -1, 0, and 1. P1 represents the 3 probabilities. Don't repeat the P here. You need a P1, P2, etc., etc. Follow the order from P, 2P to 1 minus 3P, okay? Next thing is I'm going to calculate sum x1 times P1. That is my expected value. Then I'm going to repeat that step and then square the x1, all the values from the list x1. So that will be my e to the ex squared, okay? Expected value of x squared. And then I just need to do, let's say, this bit minus this bit, whole thing squared. So expected value of x squared minus the square of the expected value x. So that will be 6p minus 16p squared. So that is option D. Okay? And that is question 14. Okay, 6 more questions to go. Question 15, a rectangle has vertices A, B, C, D, and a C has a pair of coordinates UV on the graph, 8 minus x cubed. So you can write u comma 8 minus u cubed. And we would like to find the maximum area of this rectangle. So the rectangle area of u is base times height, u times 8 minus u to the power 3. Notice that at this point, this value u should lie between 0 and 2. And I'm trying to maximize this quartic function between 0 and 2. That's all I need. But remember, you have to find, let's say, the maximum area rather than the u value. So let's say a of u is assigned to u times 8 minus u to the power 3. Then f maximum a of u with respect to u between 0 and 2. So many students, if they got this far, they would tend to select a, but this is the variable. You have to say a of 2 to the power 1/3. That gives you 6 times 2 to the power 1/3. So that's option B. Okay? Like technically, it's like a dash u equals to 0, gives you u equals to 2 to the power 1/3. Therefore, a maximum equals to a at 2 to the power 1/3. That is 6. That is 6 times 2 to the power 1/3. Okay? All right, let me just zoom in a little bit for this question 16. It's a bit blurry. For a random sample of 5 Australians, okay, n equals to 5. P hat is a random variable that represents the proportion who live in the capital city. Given that probability P hat equal to 0 is 1 out of 243, then probability P hat greater than 0.6. So now, P hat, according to the definition, is any x divided by n. And in this case, is x divided by 5. What does x mean? X means the number of people in this sample to live in a capital city. So it's a binomial, n equals to 5. And P is the proportion of any person living in a capital city, okay? And then if I look at P hat equal to 0, that is probability x equals to 0. So it's 5 choose 0 times P to the power 0 times 1 minus P to the power 5 equals to 1 out of 243, okay? The next thing is we will need to get the p-value and then probability p hat greater than 0.6 is like probability x greater than 3. If you multiply both things by 5, and then you actually calculate the probability for less than or equal to x less than or equal to 5, something along this line, use binomial CDF. So I'm going to solve an equation. This equation is 1 minus p to the power 5 equals to 1 over 243. So I'm going to say 1 minus p to the power 5 equals to 1 over 143, comma p. And p is 2/3. Therefore, I can calculate the binomial CDF. 5 2/3 from 4 to 5. Okay, something along this line. So then menu 5 5 boy. Number of tries is 5. P is 2/3. Lower bound of 4, upper bound of 5. So the answer is 0.4609, blah, blah, blah. And it's option C. Problem solved. 4 more questions to go. Let's have a look. Question 17 was deemed to be a challenging question. The graph of f, where f minus x equals to f of x, is shown below. First, this indicates the polynomial is an even function, maybe a quartic function. Next thing is this b is minus c, or this c is minus b, okay? And this is, let's say, minus a, 0, okay? And this might be minus a. We would like to find the area bounded by the curve and the x-axis on the interval a to d. So for example, you might want to express this chunk as a to b fx dx. Okay, that's the area. And this bit, accordingly, it's c to d fx dx. But it's also equal to a to b f of x dx because of symmetry. Now, you have to be really careful with the bottom part. It has one part here and one part here. So this B to C region underneath the x-axis is a negative region, okay? When you calculate the integral, it's a signed area, negatively signed area. So to find the actual area, I could say, okay, this is 0, by the way. It's twice, let's say, b to 0, f of x dx. But if you just calculate this bit, it will be a negative value. So to get an area, I need to put an extra negative in front, okay? So altogether, the area should be that add that, plus negative 2, b to 0, okay? Which will indicate option D. And by the way, why didn't I see a 0 here? Because b plus c must be 0. B equals to minus c. Therefore, b plus c must be equal to 0. So this is the only correct answer. And this one is no good because it's the total signed area. Okay? And this one, it's no good because a to b, yep, that's fine. Minus c to b. The order is wrong, okay? If you already flipped the order, then you don't have to put a negative here. So that's why this option is no good. And a to b twice, yep, that's fine. But if you look at b to c, this one's supposed to have a negative there to really get the actual magnitude of the area. And the last one, c to b, a to b is fine. C to b flipped, okay. But then d to c. This should be C to D. Otherwise, it will result in a negative region, okay? So question 17 is a good conceptual question. All right, question 18. Let x be a discrete random variable with a binomial distribution x following binomial NP. The mean and the standard deviation of this distribution are equal. So one condition is n times p equals to n times p times 1 minus p, okay? So this is the first thing. The next thing is, if you look at the smallest number of trials and such that p is less than or equal to 0.01. We need P in terms of N. To create an expression of P in terms of N and make it less than or equal to 0.01. Okay, so that's two things I'm going to use. Firstly, I'll say N times P equals to N times P times 1 minus P, comma, rearrange to get a P. Sorry, the standard deviation, bear with me, not a variance. So I have to put a square root here. Otherwise, it doesn't give me the correct result. So I'm going to get a square root here. That's much better. We ignore P equals to 0 and N equals to 0 because P must be between 0 and 1. The next thing I'm going to do is solve button. This bit is less than or equal to 0.01, comma, N. And you will see it's either N less than minus 1 or N is greater than or equal to 99. So I'm going to select option D, okay? All right, so that is question 18. Question 19 is a very, very straightforward probability density function question. If it's a probability density function, the integration over k to k plus 1 cosine x plus 1 dx equal to 1, okay? The total area over the effective region should be equal to 1. And then we just need to solve that for k between 0 and 2, okay? So that is all we need. Like we solve shift plus k to k plus 1 cosine x plus 1 dx equals to 1 for k, given that 0 less than k less than 2. So there we go, option D. K equals to pi minus 1 divided by 2. And by the way, if you want to verify whether or not this is, probability density function, I probably can graph it over the domain. Let's say pi minus 1 divided by 2 less than x less than pi minus 1 divided by 2 plus 1. Good thing is this section is indeed above the it's indeed above the x-axis. So this region will be a positive area, okay? There's no part of this function below the x-axis, so we are all good. Okay, lastly, we have two graphs here, cosine x and √3 sine x. We would like to find the ratio of the area of the shaded region to the area of the triangle. So the shaded region, we need to split out to integral. And what is this? Well, if you equate cosine x to √3 sine x, you'll be able to get, for example, sine x divided by cosine x equals to 1 over square root of 3. And therefore, you get a tangent x equals to 1 over square root of 3. So the first value here is x equals to pi over 6. Now, it's a ratio. The ratio has the top part like a 0 to pi on 6, and it's √3 sine x dx. The other part is under the graph cosine x, from pi on 6 to half pi cosine x dx. So that is the actual shaded area divided by the area of the triangle. So if you sub in pi on 6 here, you'll be able to get pi on 6. Cosine pi on 6 is √3 on 2. So the area of the triangle is half base times height. So you have half times base is half pi times √3 on 2. So eventually the bottom should look like √3 pi divided by 8. And this one doesn't have a √3 pi over 8. So I can only choose between B and E. Apparently, this area is not equal to 1. So I just need to use my CAS to figure out the sum of these two expressions. Say, okay, integral 0 to pi on 6 square root of 3 sine x dx plus an integral pi on 6 to pi on 2 cosine of x dx. Root 3 minus 1, so option D. Okay, so that is our desired answer. All right, that's the end of my workthrough. Hopefully you find this one useful. I'll see you another time. Bye-bye.